Okay, I would like to take one look at the timing diagrams, right? The timing diagrams, like we've been saying that when you're fitting your data into your shift registers, it's very important to know whether you're fitting left, if you are going to shift left, you are going to shift right. Okay, it's very important. Let's say you've got data. All right, what are we dealing with here? The timing diagrams. We want to say, let's have a what call this clock pulse. Let's say now with our clock pulse, what we want to do, we want to uh, shift a certain data in a certain direction now. All right, let's start obviously with the shift, with the left shift. Let's not obviously, but let's just start with the left shift. Let's say with the left shift register. All right, left shift, left. I should have just said left shift. Let's say we want to shift the number 1011001. Okay, we are going to use the left shift to shift the number 1010 what 11. What are we going to do? Probably mark out, first of all, decide what shift, what type of filters are we using. Are we using leading edge type, or are we using what call this trailing edge type? Now, what do you mean here? We mean, is it just normal latches, or is it master slaves? All right. So let's suppose, so you either have a response on the leading edges, or let me rather try this other tool, because I really think it will be faster in terms of where are those tools? No, 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 no. I just forget where my tools are. Probably let me say line width, line mode, dot. Let me probably use these. Are these dots? These are not dots. Let me rather use this because it takes less time. Okay. Let me use, oh, okay. Let me move this here. Clone it. And put it in every edge. I'll put it in every edge. Why am I putting it in every edge? Ah, man. Not. Okay. I'd rather clone them. Let me rather clone all of them. Okay, and drag them all at once. Okay, let me clone and drag. Hopefully they don't differ by much. Let's just ignore the little variations there. All right, let me, okay, I'll probably have to delete this. Okay, and just try to get, okay, let me not suffer unnecessarily. Let me suppose they were enough. Delete. Let's suppose these were enough. Let me move, in case I will need to demonstrate something else. Let me move a little, because it really doesn't want me to play in the other space. Now let's suppose ungroup. Let's suppose I want to see if any of them are still grouped. Ungroup. I want to make sure that none of them is grouped. Okay. ungroup. Just want to make sure they can move as individuals. Okay. Ungroup. Okay. It's still a lot of work as far as I'm concerned. Probably should do this before I start my class. Okay. Okay. Alright, that took longer than I wanted. But anyway, let's go and say, let's suppose now we want to have our data. Okay, what we'll do is I'll say my input is given as, now I'm shifting left. If I'm shifting left, obviously I am going from right to left. So this is my MSD. If you are shifting left, MSD goes first. So what do you mean there? We mean that the 1 will go first, followed by the 0, followed by the 1, by another 1. I'm reading number backwards, followed by a 0, there's another 0, and finally a 1. Okay, and then now the issue is I am dealing with what? With this what call this? With this what I would call leading edge type. Now what will my data then do is I put my data on the what? On the leading edge. Alright, what I'll then do is I'm shifting left, so I'm going to be feeding the what? The least significant first. Okay, the MSD is fed into the least significant, going towards the space which is the what? The most significant space. So what we'll then have is what? We'll have our Q. Let's say we're asked to use 4. This will be Q2, Q4 and Q8. If we asked to have 4, we could have been asked for more or less, doesn't really matter. Let's suppose at that point we had, let's really be practical. We'll say, okay, left shift. Why we use the reset is because we may want actually to, why is it making me struggle? All right, we may want to reset the data first. Let's say at that point there we reset our data. Okay, what then happens is that if anything here, our whatever the values that our, let's suppose we had a 1, we have to mark this one. I'll probably need to use that one as well, but this is only 1. I'll quickly do it. So we have to mark this one. So because if this was a 1 at reset, it will go to 0. Let's suppose that was also a 1, it will go to 0. Let's suppose this was a 0, it will stay 0. Let's suppose that was a what? A 1, it will at reset go to 0. They stay what they are until another interrupt or until. So let's suppose that was 1 with 1 0 1 1, and then we reset and we went to zeros. What happens then is very easy. With because it's a leading edge type, with the leading edge, how do you know? Your clock, it has to be the type where your clock is going direct. Okay, so meaning that is not what is not master slave. With master slave, the other one, remember this is just a reminder. This comes from a direct clock, and it's going to be leading edge, and this comes from what? An inverted clock, and this is going to be trailing edge, and that is the master slave type. All right, so now the input here is simply going to slide through. Probably I should have swapped the input and thing. This 1 0, I'm only worried about the what am I doing? No, I didn't notice this. I made a big mistake here. This is not proper. This is not proper. This is not fed in proper. I'm noticing now that I have to put my data in. That's not fed proper. Now, if the information is a 1, we are fitting from the MSD going that way with the what? With this left shift. So we are fitting a 1. That 1 is kept right through. Okay, it's going to be what call this change to a 0, kept right through, because that's that we are fitting. On that pass there, on that leading one there, we are going to go to a what? To a 1. Stay. Then just before that, we go to we keep it a 1. Now just before that one there, we feed a 0. Just before the 6th one, so 1 2 3 4 5 6 7 passes. Okay, then that's another 0. Then on the 7th pass, then it becomes a what? A 1. Okay, so probably we don't really care about the rest. Let's say it's 1 1 1. All right, if there is nothing else, probably it wouldn't be proper for me to say 1 1 1, because there's nothing else. Probably after the 7th one, nothing else is put in, nothing else is considered what? Zeros. Okay, let's say 0 if the rest, meaning we didn't fit anything anymore, so there's nothing that will come through. So it means I would probably have to end it what? After 7. All right, this one I would have to end it after 1 2 3 4 5 6 7. So I would have had to end it at what? At 7. So this here will stay, because it's leading edge. At the leading edge, it looks the input is a 1, so that goes to 1. The input is a 1, so that will go to climb up to 1 and stay 1 until the next leading edge. But I know it's going to be here. It's going to be fed as 0, so I can draw this one right out. It's going to be fed as 0. And the next leading edge is being fed a 1. At the next leading edge is being fed another 1. At the next leading edge is being fed a 0. 2 zeros in succession. So next leading edge is going to continue a 0. Then it's fed a 1. And if we really worry about the rest, it's going to be fed in zeros the rest, because our information is done. All right, we could have ended there. Now, what do you see? This 1 slid through, this 0 slid through, that 1 slid through, this 0 slid through, that 1 slid through, and that 0 slid through. Okay, so what do we have? Oh, we have this 0 sliding through. We have another 0 sliding through. Yes, we skip that. We have a 1 here. All right, if you get our number, it's 1 0 1 1 0 0 1. So all we did was write that number as it was there. So we fed this one first, because we are going left. We fed this one first, we fed that one second. So we fed first pulse was 1, second one was 0, third one was 1, fourth one was 1, fifth one was 0, sixth one was 0, last one was 1. Okay, the rest doesn't matter, it's zeros. All right, so then what you then do is Q1, when we had a leading edge here, Q1 was a 0. So what happened is that this 0 is fed through to what? To Q2. Okay, at that point that one was found as a 1, it was fed in. So the rest is easy because that one is fed in. It's a 1 now is fed in. So another 1 now is fed in. Is that 0 is fed in. 0 is fed in. That one is a 1 is fed in. The rest is zeros and they. Alright. Now what are you seeing is that this one was fed through, that one was fed through, that one was fed through. They are being fed across. Okay, that one was fed through, that one was fed through, that one was fed through. That 0 is successful. Okay, the zeros don't matter anymore because they what? There's nothing more. Now, when you look at the what? The Q2, it was fed by Q1, so it was initially reset. So the 0 was fed through, that one was fed through, the 1 was fed through, the 0 was fed across, that 1 was fed across, that 1 was fed across, that 0 was fed across, that 0 was fed across, that 1 was fed across, 0 was fed across, but it doesn't really matter because our data is finished. Now, when we go next, we go to this one is fed by the Q2, so it's fed a 0, it's fed another 0, it's fed a 1, it's fed a 0, it's fed a 1, it's fed a 1, it's fed a 1, it's fed a 0, it's fed a 0, it's fed a 1, and our data is finished. All right. So the question can be, all right, before we do that, we have to do the last one. That one is a 0, is fed through. That one is a 0, is fed through. This 0 is fed through. That one is a 0, is fed through. 1, 2, 3, yes. And then that one is a 1, is fed through. So it has taken how many? We've got 1, 2, 3, 4 flip-flops. It has taken what? It has taken 4, what call this? 4 clock pulses for the first one to be fed through. All right. So what then happens is that the 1 is fed through. Okay. The 0 is fed through. That one was fed through is a 1. That one is a 1 fed through. That one is a 0. Notice how I'm sliding my pointer. So this one is fed through, it's a 0. That one is fed through, it's a 0. And that one is fed through. So what do you notice? You notice that the reaction has been taking place on the leading edge. The reaction has been taking place on the leading edge because we said we are dealing first with what? With a leading edge type. All right. If we're dealing with the what? If we're dealing with the trailing edge, the same thing would have been happening, but it would have been happening on that what? On that edge right there. Okay. That edge right there. That edge right there. That edge right there. So what I'll do is when I do the shift right, I've done the what? The shift left, and I've used a what? The leading edge type. I'm gonna go now and do what? And do the what go? So you see, for the first one, the change took place in half a cycle. For the rest, it was taking a full cycle. A full cycle. For the rest, it was taking a full cycle. But the first one was what? Half a cycle. As a reminder, again, we've done this before. So with this left shift, I've used leading edge. I'm going to use trailing edge with what? Just to show you the difference, right? How the two reactions differ. So what I'll do is, this was left shift. I hope you understood. The data was fed from the most significant and was fed to Q1 first and was sliding through. Now I will go on and demonstrate in the same space so that people understand what we're talking about here. I wish I could have a different color pen. Is that even possible? Let me change a different to a different pen and probably say, let me use one that will be very visible. I think that's visible. Okay, now what I'll do is I'll use the same platform for what? For a right shift, but for the right shift what I'll do is the input will be for the right shift, or maybe should I do the same thing with the left shift? No, let me do the right shift. The input, I wanted to write right shift, I got lost to my thoughts. Right shift. For the left shift we chose to use black. For the right shift, what did we do? We said we're going to use what? We're going to use trailing edge for the right shift. So what I'll do is I'll indicate that my right shift is going to be okay, red. Okay, now also my input is going to be red. So for that one I used, because the clock, the what call this, the type of flip-flop I was using was what, or what am I doing? I'm trying to erase. The type of flip-flop that I was using was this one, where the clock goes direct. It's not a master slave. Now I'm going to opt for a master slave, and with the master slave I'm going to indicate that the red represents what? The master slave. Okay, so our clock is going to be, again, a reminder, trailing edge. So what I'm then going to do is I'm going to say, I wonder whether it won't look clumsy together here. Probably move this down first. Okay, so I'll then say my input, nope, my input for that one, if it's right shift, this is going to be the what? The one that goes in first, going into what? This one went to, this one is going to go first into what? Into the what? Into the MSD and slide. Okay, this one is going to go first, MSD first. Okay, LSD is going to go into MSD first, whereas with the other situation there, what we had was MSD goes into what? Into LSD first. I think I must write that one down. MSD first. Okay, I think I must put that difference down. Now what we have is that we are going to use, go back to our pen and say, our input now is going to be that one first, the LSD. So our input is going to be, let me first, no, this will not work. This will not work. Why won't this work? Let me rather remove the old one, the old input, because now I can see why it won't work. I'll explain. Let me just quickly, okay, remove this. It won't work. Okay, what we'll do is we'll change our input. We'll remove this guy. Oh, it's grouped. Okay, so what we'll do is ungroup and hope that nothing else is grouped. So I'll remove this. Oh god, a lot of sweeping has to be done here. Oh god, I have to, maybe I have to just draw through the whole line and go like this. That will be probably quicker. Yeah. Okay, did it matter? That part didn't matter really, but what's done is done. So we'll leave some of the things that are a little bit difficult to deal with. Okay, trying to go as quick as I can. Oh, but sometimes rushing will result in a crash. So, whereas again, time is money. You see now. Okay. Oh, no, I'll leave that. Oh, okay. So probably, no, I'm not gonna do that. If I do this, let me experiment. No, I'm not gonna do that. Let me not worry about useless things. It's gonna consume our time. So what I'll then do is I'll say our input. Do we still have the same pen? Yes. Our input, let's say we have our reset data, somewhere there, and we know it stays on 1 unless when you reset, so it went to 0 because we were resetting here. So yes, we are not afraid of what it was before. Probably this was a 1, it's reset to a 0. This was a 1, it's reset to a 0. This was a 0, it stayed 0. This was a 1, it reset to a 0. Okay, so what then happens is that we have our data, but now we are using what? We said we are going to use the one that uses what? That uses a trailing edge. So our response is going to be on the what? On the trailing edge. So our input is now going to go 1 first, and then the 0 is going to go because this will go first, that will go second one. So our first pulse will feed this one, our second pulse will feed that one. So when you are shifting what? When you are shifting right, we start with the LSD and we follow all the way up to the MSD. So with this one here, our first beat would be first clock will see a 1, the second one will see a 0. I'm making sure that my trailing edge sees what I need to see. So I need to see a 1 first, I need to see a 0 next, I need to see a 1. So the third one will see a 1, the fourth one will see a 1. I'm looking at trailing edges, and the next two are going to see zeros. So my trailing edge is going to be a 0 there, my other trailing edge is going to be a 0 there, and then it's going to be a 1. If that's all the data, so our trailing edge must say 1. If that's all the data we have from that point, it can go 0 because it's nothing else. If nothing else obviously is a what? Is a 0. I'm not going to, I'm going to have a problem there because if I say back, let's see what happens. Alright, after 7 it's a 1. Then I'm going to try to be careful not to slide into the space of that, because here it doesn't matter what it is anymore, as long as my data 1 0 0 1 1 0. No, what am I doing? Hey, wow, what have I been doing for a while? I skipped a 0 1 1 0 0 1. When it's under, it's a 0. When it's on top, it's a 1. So the rest doesn't matter, it's just zeros. The rest does not matter, it's just zeros, right? But I'm worried about first clock pulse, we'll see a 1. Second one, we'll see a 0. So it really matters. When I was shifting left, I started with this one and that one and that. So you have to be very careful about that. Okay. When you're shifting right, we start with that one and we are going right. Okay. So I hope that this really will clarify a few things that people had a problem with. So this is I'll say the input for the right shift. So can we then be feeding to this? When I'm feeding here, I am feeding first to my MSD. So I cannot have the same order there. My order here is going to be Q8 first, Q4 next, Q2 next, and Q1 last. Because when you're fitting towards, when it's a right shift, we feed at the left, and the left is the MSD, and you are shifting towards the what? So what you then do is very simple, is the trailing edge, because it's a trailing edge type. Trailing edge, our data goes through. So here, this will stay until a trailing edge, the 0. After resetting, all those zeros will stay until the trailing edge where the flip-flop opens. Now the flip-flop is seeing a 1 on the input, so Q8 goes to 1. It's seeing a 0, it's going to go to, second pass is going to see a 0. It's going to see a 1, so it's going to go to a 1. It's going to see a 1, it's going to go stay a 1. It's going to see a 0, it's going to go to 0. It's going to see a 0, it's going to stay a 0. It's seeing a 1, it's going to go to a 1. Okay, the rest doesn't matter. It's seeing a 0, but this is now having no data coming through. Okay, so this one, oh, what did I do? This 1 came through, that 0 came through. Look how I'm sliding across. That came through was what was waiting at the input of Q8 was the input. All right, so then this one would see a 0 is being fed by Q2, Q4. Remember, when we're shifting to the right, Q8 feeds Q4. So Q4 was fed a 0, then a 1, then a 0, then 2 1s, 1 2 1 2, then a 0, 2 zeros, 1 2, then a 1 finally. But then it was fed nothing else, meaning zeros would follow. Okay, then Q4 feeds Q2 when you are going to the right. So when you are going to the right, so that's a 0, stay 0. That's a 0, stay 0. Then it's fed a 1. Then it's fed a 0. Then it's fed a 1. Then it's fed 2 zeros. What I do? It's fed a 0, it's fed a 1, it's fed a 1. Not, what did I do? When did this come in? Okay, I'll come back to that. This is fed a 1 across, fed a 1 across, fed a 0, fed a 0, fed a 1. Okay, finally Q1 is being fed by Q2 when you're going right. So here is fed a 0, here is fed a 0, here is fed a 0, now it's fed a 1. Again, there are 4 flip-flops, and that first one there appears after 4 what? There was a delay of what? Of 4 clock pulses, because there are 4 flip-flops. Another thing, that the initial delay was a full clock pulse. Remember, with the what? With the one that is leading edge, the initial one was what? Was a half of a clock pulse. But in this case here, the initial delay is a full clock pulse, but then it took 4 clock pulses for the what? For the first digit to come across, because there's what? To come out, because there's what? There is what you call? There is 4 flip-flops being used. Now that one was fed across, that 0 is fed across, the 2 1s are fed, 1 2 in succession, 2 1s, the 0, another 0, and we probably lost a what? Would have probably needed a what? Would have needed, there is a what? Would have needed this one there. In fact, we have a what? We have an edge there, so we have to be very, very careful. That 0 would have been fed across. That little bit can be shown there. Okay, there was a 0, that 0 will fed across. There was a 0, that 0 will be fed across. There was a 1. Okay, there was the input was nothing, so this 0 was fed across. This 0 was fed across. And I've done this one already. Okay, so probably we don't need a what? Another clock pulse, because all the data is what? Has gone through. Now you could be asked, even with the previous example, you could be asked what the reading would be after 6 clock pulses. Then if you are asked what is the reading after 6 clock pulses, you simply say it is what? How do you write it? We write it obviously with the what? With the most significant first. Ne? So after 6 clock pulses, we are reading 0, that MSD 0, that Q8 0, 1 1 0, 0 1 1 0. This is what would read after what? After 6 clock pulses. So you could have had a question, what would your register read after what? After 8 clock pulses, it will be this reading here, which will be after 8 clock pulses. This is after 6. After, I'm going another example, after 8 clock pulses, it would have been, you start with the highest one. The highest one is a 1, 0. Oh, there's a 0 and a 1. After 8, it would have been 1, 2 zeros and a 1. So you can be asked, text or exam question, what will be the reading after so many clock pulses, all right? So with that, I've basically covered everything that I could. Well, unless I receive questions, probably I could look at specific scenarios, but I've covered what I would have loved to cover. So I've done the timing diagrams, I've done all the variations, I've done the different types of flip-flops. Okay, so I think at this point it is not a very what call this, warm day today. So I think I'll appreciate a break now. Cheerio. I hope we had fun. Can't even see anymore.